the slide up on the... How do I get it off the screen, guys? There we go. All righty. Thank you. Okay. Hi, I'm Josh Carroll. I work for Royal Bank of Canada Capital Markets. I'm based here in the US. And today we're going to talk on go big or go home. We'll get into the context of that in a few minutes, but I just thought I'd give you a bit background on RBC Capital Markets, and then we'll get into the context of the talk and how that relates to APIs. So my group, and what do? I run a group of about 150 people across multiple geographies. Just started traveling again recently, so starting to get to see people in person. Great to have people here in the room today. My teams are based across US, Canada, UK, Asia Pacific. And as you can see on the screen, there's quite a varied group of people, everything from architecture, which is a more recent role for myself, to big data, to containerization, to market data technology, chatbots, and quite a varied thing. And one of the coolest things I get to do in my job is actually name chatbots. And one of the ones that I did name was Hillary, that helps you delete messages. So a little context there for you. Anyway, getting into RBC Capital Markets. I've been with the company since 2009. I joined from Merrill Lynch back in the financial crisis. I was based in London at the time, and I moved here in 2014 with RBC. We're a top 10 global investment bank, if you're not aware of who we are. We've got offices all around the world. I have had the fortune to travel to most of those offices over time, having been with the company for 13 years. And we've really grown our footprint from when I joined in 2009 to 2022. And a lot of that was because we weren't really involved in any of the financial crisis that impacted so many of our competitors. And we've been able to spend and invest. And what I'm going to talk about today gives you that history and where we've got to and why that's been so important for the last sort of 10 years of what we've been doing. So, go big or go home. What's this about? So these are probably familiar things that you may have seen, and some of the well-known technology companies in the world, LinkedIn's, the Amazons, the Facebooks. I know I'm a frequent user of LinkedIn. I open LinkedIn and I get the, oops, sorry, something went wrong. Within a financial organization, unfortunately, we can't really build things that just tell our customers, oops, things went wrong, because when you're using trading systems and you're using people's money or your own money to trade, there cannot be faults like this. And whilst this might be okay if you're watching Netflix or you're going to Amazon and you can't buy something, you're going to come back later on. In the financial industry, we can't have those kind of days. And so a lot of our technology, and a lot of technology that I'm even using today, particularly in the big data space, a lot of that stuff, it's enterprise technology, but it's not enterprise grade, right? So yes, it works at scale, but does it work every day, all day? And the answer to that is probably not for a lot of these things. And these big companies, even Facebook, for example, they've had very, well-known outages. And equally, as a Canadian company, there was a Rogers outage for telecommunications that was very well publicized a few weeks ago. I was actually in Canada during that day, and no one could use their mobile phones if you're on the Rogers network. So we can't really have those kind of days. We'll lose customers, they won't come back. It will impact our bottom line. So the systems that I have to build have to work every day, all day. So what I'm going to talk about is APIs and our event-driven architecture that we've built over the last 12 years actually now in production. The last 2 years always gets a bit of a blur for me. I keep saying 10 years, but really it's been 12 years in production we've been using what I'm going to walk through. And the events that we flow through the system I'm going to walk you through today, and the APIs that we've built on top of that, have enabled us as a business that in pre-COVID 2020, we're doing 67 billion messages a day. All the way through, COVID kicked off 94 billion messages, a massive jump in the events there. And I thought we're not going to hit those kind of numbers again. And then obviously just as we come out of COVID, we have the Ukraine and Russia war starts, and all of a sudden our message growth goes through the roof again. So in 2 years, we've gone to 100% growth in our events across our environment, and we aren't allowed to have any of those kind of days where, oops, something went wrong. It's just not allowed in our industry. Having dealt with a lot of the other sort of technologies in this space, and we have every piece of technology in the organization, some of these things don't work in that kind of way. So what is the size of my business? I am sending these events across my platform 24 hours a day, 7 days a week. And to put that into some kind of scale, it's over 1 million messages a second, 24 hours a day, okay? And all the text messages, so SMS text messages in the world, there's only about 20 billion messages a day, and all the WhatsApp messages in the world, just to give you a scale number here, is about 100 billion. And for the last few years, all the messages we send as a business within capital markets has pretty much stepped in line with what WhatsApp does. However, if you're familiar with WhatsApp, you know you might be sending a small text message with just a few characters in it, you know, hi, how you doing, meet you later kind of thing. The business messages we send over this are maybe up to 1,000 kilobytes, a meg, a few meg in size, and none of those can go missing. So we send this data, it's all connected up between Tokyo, Sydney, Singapore. We actually had Hong Kong, I've just taken it off the map, we've just moved out of Hong Kong, so we were 7 geographies up to about a month ago. We've actually just shut down our Hong Kong office and moved everyone to Singapore. And we're flowing 124 billion messages through our system every single day in a seamless way. And we've done that through APIs that we've developed and support on top of vendor technologies. So that's the platform overview. This is a daily email that I get, and I get this email every day. It tells me how many messages we flow through the system. So our current peak of messages, 16th of June, 124 billion. It shows me the previous day in the last 12 months that was bigger, so I can do contextualization and colorization to show me, okay, anything that's orange on here means it set a new record. So I get this every single day, and I can tell you yesterday we did 94 billion messages. For a lot of industries, and even if I look at my enterprise organization, we only do less than 1 billion messages in the enterprise at RBC. So capital markets is outstripping the number of events that occurs in my whole enterprise bank by like a factor of like almost 200-300 times the amount of data that they do. And the reality is, the reason we've managed to do that is because once you start connecting up your business at scale like this, which we've been doing for 12 years, you start to enable things that you never thought were possible to begin with. So we didn't start off with 100 billion events. As you can see, we were 67 billion back in February 2020. But we've been on this journey for almost 12 years, and it takes years to move systems to this kind of, event-driven architecture and having APIs supporting that, and we'll get to the API piece of that in a second. But you can't do any of this overnight. And once you start connecting things up, what you tend to find is we're now actually the biggest thing on our network. Because applications can talk to each other in ways they never even thought possible. And it doesn't become a problem then for someone who wants to onboard a system. It's something that's very seamlessly happens. We have a very tight architecture and governance model around it, which I'll talk about in a second. So where were we back in 2010? We had a lot of market data systems, which is where this sort of got spawned out of. Market data has been a messaging environment for many years, a way that, if I talk to people about messaging back in 2010, most organizations, retail or whatever, had no concept of, they didn't think of their world as being messaging. Now I sit and hear retailers talk about, real-time flow of information, knowing where their produce is and whether it's getting to their supermarket or not. Those kind of people didn't really have those kind of ideas. So we were tied to existing platforms. Some of these will be probably familiar, things like IBM MQ, etc. And we had a huge footprint, so I had about 500 servers delivering this data between all my environments, and some of those vendors wanted to charge me more data based on the amount of data I was sending. That's not a scalable model. We wanted to be able to dynamically query the environment without causing impact. We wanted to free ourselves from our technology vendors so we weren't held into, when doing negotiations over price for data delivery, we didn't want them to be our technology provider. We want to separate those two things out, and the ability to scale quickly. So that's what the things we were looking for. And this is really, what makes up my architecture today. So it's obviously big data. We have to monitor this and have capacity planning around it. It's a single environment that's cloud connected. And the focus obviously today being an API event, we'll talk about the API that we've built and the standardized wrappers and the speed that then people can adopt those. So what does that look like for us? So obviously for an event-driven architecture, we want to be able to publish once, subscribe many, publish point-to-point, request reply, streaming, and aggregation into a single, multiple protocols. We don't want to be locked into any one protocol, open standards. And what we found, we went out and looked at the whole street at the time, this is like 12 years ago, we actually tied it down to about 2 vendors. So one was 29 West, which is now a company called Informatica, and Solus. And so we went with Solus, and actually there's been a positive externality to that, a saving that we didn't even think about at the time. So cloud didn't exist in 2010. It was all hardware on premise. And my footprint shrunk from about 500 commodity servers to 60 appliances. So my data center footprint shrunk. My cost of running my environment shrunk. And now, obviously, as we move into the cloud, we've got that seamless operability between environments. So we are sending all this data between all my on-premise applications. We're connected up to Azure and AWS. We're able to use the same APIs that we're using on-premise in the cloud. I can take data from Azure, move it to AWS, take data from AWS, bring it back on-premise, take it out again. So we're using this to move big data from our on-premise environment today into the cloud. So there's a financial regulation came in during COVID, something called Consolidated Audit Trail in the financial industry. And this means that we have to publish reports to regulators at 7 a.m. every morning, and if we don't, we get fined. And we have had to deal with, during COVID and now Russia, like 2 or 3 or 4x data on any given day compared to the previous day. Well, if you start trying to scale that in your own data centers, you're sitting there waiting for what we call black swan days, and paying for hardware that you don't need to use for a large majority of the time. So by being able to seamlessly flex our data out into the public cloud, produce the reports, bring those back and send them to regulators, we're able to save money and also get agility and speed into doing that. So we've built out our architecture that allows us to do this. And this is what it looks like from an actual physical implementation. So we have storage that's connected to these devices. We have last value caches. And these are all meshed up. So when we first put this architecture together and the APIs that we built on top of it, we spent a long time looking at our topic structure and our governance. And so today, if you want to onboard an application, you fill out an onboarding request, and literally within minutes from that and the approval process, that can then be generating a request that will automate the permissions, because that's the only thing that's actually required to get onto the system is permissions that can be automated and implemented. So there's actually no human needed to implement a new system coming online. So I can do that in the middle of the day. I can add an application, seamlessly add it in, all through APIs that we've built in the background around automation of entitlement and governance and authorization. And then, so you build your application, you go through your QA and development. And I equally, in my QA and development environments, one of the things I've been lucky enough to do is that I actually enact failures every single day in QA, and every week I do a DR test. So I fail things over every week to DR in QA, and every day I do a failure. So no application can ever get into production that hasn't gone through a daily failure test and a weekly DR test. So because things happen in production all the time, and back to my you can't have any oops days, right? Like this, hardware fails, things will fail, technology infrastructure fails, and when that happens, being able to seamlessly fail over and continue in the banking industry is extremely important. So that's the physical implementation, and as you'll see there, we're using the virtual environments in AWS and Azure to seamlessly connect this up. I haven't got the whole architecture on the page, it doesn't fit easily. And it all comes back to the APIs that we're using. One of the very popular sort of event-driven architectures in the street is Kafka. I'm sure there's plenty of people very familiar with that in this room. But what we find with that is you're locked into that specific vendor. There is Apache Kafka, but it doesn't scale in the same way as we have found when looking at our event-driven architecture, where here we can use all kinds of open standard protocols that are not tied to any vendor. Yes, we've got a vendor in the middle of that using the event broker, but we're eliminating vendor lock-in from a protocol perspective. So we can be using JMS, we can be using REST, we can be using MQTT, we could use Solid's own proprietary APIs, or we could be using WebSockets, JavaScript. There's so many ways that we're opening ourselves up here. And then I have a team that supports the integration of all of these different APIs to get onto our platform. So I have a dedicated development team whose only job it is to integrate with these APIs and provide a wrapper on top of them so you can get up to speed quickly. So therefore, from a business capabilities point of view, you don't have to worry about how you're doing event-driven architecture. That's taken care of for you. You want to know about how you're going to take data from the business and send it between applications, but you don't have to worry about the technology stack that lives under that. You take the wrapper API that we produce that sits on top of any one of these protocols. So if you're bringing a third-party vendor in and they're like, hey, they only use JMS, okay, great, we can support you. And so your time to market and your agility is extremely key on not having to worry about those kind of things at an application level. So back to David was talking earlier about business capabilities. It's enabling people to not worry about the tech stack that sits under them. They can just be worrying about what they want to deliver from a business point of view, and then the technology delivers that for them. This is just a view of the different wrappers that we do. And as you can see, we're touching everything from Python to C to real-time to JavaScript. And our RBC DX platform, which is our external-facing FX platform, is all sitting on this technology and is using JavaScript as an example. So now to get to this perspective, we had to spend a lot of time up front thinking about our architecture and our topic schema, and I'll touch on that in a minute, and I'll show you an example of what that is. But in some situations, you can't necessarily build a wrapper on top of an API, and so we just set some minimum standards and said, okay, if you can't take our wrappers and you're bringing an API into the platform, you just need to meet to some minimum specifications so you can get up to speed quickly and equally survive on the platform in the event of hardware failures and stuff like that. So I've put the minimum spec of what we've put into our APIs and wrappers that we support on top of any of the APIs that exist out there. So it's things like, as it says here, sender ID. Well, you want to be able to know where did a message come from. If you want to trace it later on, if you don't put that in there, a lot of APIs off the shelf won't give you like that information. You have to put it in there. So that sender timestamp, auto reconnecting in the event of failures. So these are all just really basic things, but we try not to bloat what we're taking off the shelf from any of the APIs that are available and just wrapping it very lightly with a quick shim. So that's the minimum spec of what we're looking for. And then we've built other things on top of that. So we've taken entitlement agents. So in our industry, Refinitiv and Bloomberg are two big data vendors. We take their data and put it onto our platform. But to do that, we have to worry about, who can see that, who's entitled to see that. So we've integrated with their entitlement system. So Refinitiv has something called DAX and Bloomberg has something called MRS that we have to conform to show who has access to the data once it flows onto my event-driven architecture. So we've integrated those into our wrappers and things like if there's a WAN outage between London and New York, we can notify clients through messages on the platform. So then they can say, okay, I'm going to be missing data from London at the moment. And when that comes back, then I'll know to start resubscribing to certain information. So we've thought about the whole global ecosystem. And obviously from an inner source perspective, we allow any of our development community to contribute to any of the wrappers that we have. So we're very open about how that can be used and reused across the groups and access to that through our internal GitHub. So these are some of the features that we built into our wrappers and things that if anyone's familiar with TIBCO's TIBCO Rendezvous, there's a similar functionality, request response. So you send a request out in the environment and get a direct response back to your application. So all of these have led to, as I mentioned earlier in our talk, we had 500 servers. We're down to just 60 appliances. That's a significant saving. We've freed ourselves from our market data vendors, so they've no control over us now when we're talking about negotiation of data feeds because we're not tied to any of their technology platforms. So that's given us real power, and we've enabled ourselves to exponentially grow our data footprint. So from a big data point of view, 67 billion messages to 124. But if I go back, say, 2015, we would have been doing maybe 10 billion messages. So this has just incrementally stepped up over time. And so we're now the biggest thing. These are 80 gig appliances that sit on the network, and we're the biggest thing on the network in the entire bank. So not just in capital markets, but in the entire of RBC. A quick view of what our topic schema looked like. So when we haven't really had to touch this in the last 12 years when we implemented it. Basically, it gives you a geography, it gives you a business type, it gives you a data type, an application, a schema. So all the kind of things, we spent a long time thinking about this. I've got a sort of 80-page reference guide that we put together, and we haven't had to touch it since. And spending time up front thinking about your architecture around your topic schema for your event-driven architecture is so key. So you don't have to revisit it, because if you're going to revisit this down the road, it becomes difficult for existing applications that have deployed. Over the last 10 years, we've created an ecosystem, everything from monitoring to replay. So we're able to replay data over an environment using CodeStreet up there in the top corner. I mentioned Bloomberg and Refinitiv. Equally, OpenFin. So in the financial industry, there's a drive towards open standards again and interoperability of the desktop. So OpenFin is another thing that we've adopted. So you can interrupt our event-driven architecture with our desktop. And we've got about 450 desktop applications integrated with OpenFin and all taking messages off our event-driven architecture. So this is the ecosystem of vendors that we've built around our platform. And then the future for us, for those who are familiar with an event-driven architecture, traceability and proving where things are in your system and applications. I didn't get a message. And it's like, well, okay, well, it was definitely sent to you. I didn't get it. So part of the sort of future roadmap of products that are being delivered at the moment are the idea of having open telemetry that will show you when a message went through every step of your event-driven architecture from an auditing point of view, so then you can prove to an application, look, this came from here, it went to here, it moved along this step, and then you tie that into an event portal that is on the bottom right there that shows you a visualization of where a message was at any given time and where it sat somewhere. So these are things that are sort of in the works at the moment from a delivery point of view, but a key to when you're dealing with something at such scale, being able to trace messages and visualize them, it becomes extremely important. And then onto my last slide, and so thanks for bearing with me over the last 20 minutes. This book was written in 2014, and for those of you who aren't familiar with the financial industry in any way, which I presume there's quite a few people in the room, this book mentions RBC quite a lot. It was written in 2014. We had no involvement in it being written, and the company was extremely worried when it was published what it was going to say about us. The technology that's in here is still used today. It's a product called Thor, and a whole exchange has been spun off this, and people left RBC over and started a whole business. But if you want to learn more about the financial industry, you want to learn more about RBC, I thoroughly recommend giving this book a read. I was finally able to explain to my parents a little idea of what I do after they read this book, because they have no clue of what I do. But if you want to learn more about RBC, give it a read. The technology that's in here, Thor, during the pandemic, we've actually rolled that out to Europe. So it's not just based in North America now, it's also based in Europe. And the technology it sits on is the event-driven architecture that I've just talked about. So I appreciate everyone's time today, and thank you very much. Any questions? I'll quickly take them.
Yeah, we have time for one question. You want to go ahead?
I'm just curious on kind of Async API and some of these other sort of standards emerging around specifying asynchronous kind of messaging that go beyond sort of like Solace or you know, more closed platforms. You know, how do you see that stuff evolving?
How do I see it evolving? I think that you want to just keep yourself agnostic as best you can. I think that so much changes when I look at technology over the last just 5 years, right, that you want to keep a pretty open mind as to anything. And, you know, I think a lot of those things are going to keep evolving quite a bit. So being able to, the ability to pivot and agile in an agile way is important in that front, as opposed to, you know, betting your house on something and deciding that you can't change. It would be my only thoughts on that.
So then in terms of like governing some of these aspects that you were talking about, where you have sort of, you know, standard elements that you're tracking, is that all just kind of in-house baked solutions for doing that?
Yeah, so we collect pretty much a lot of metadata across the platform, and the governance process is all enforced. So yeah, we've got data lineage tools, etc., and so you can, you know, get a view into the data cycle. Okay, thanks everyone.